Hey everybody, let's well, yeah, I hope you're all having a great week so far and you had a great weekend. Oh, mine was a bit crazy. If you hadn't seen on my Twitch status, my house was actually struck by lightning last Thursday, and so it blew out a lot of my electronics, including my modem, but they came by and fixed it, so that's not a big issue. But and then I found out after they fixed that is that my computer's network adapter was also fried, so unfortunately I have to stick to a wireless connection now, and I'm not really sure how stable it will be for streaming, so I do want to apologize ahead of time if I have to stop in the middle, but it seems to be holding up fine for now. And I guess with that, let's go ahead and start. So we are still working on the pathfinding system. Specifically, we finished a lot of the groundwork, and now we're going to start testing. Yeah, so these are just some of our goals. Once we've done the first pass, I'll come through and check off the ones that we verified to work. Oh yes, and there was a strange bug last time I streamed where the Unity pretty much just gave me a blank error and said that it couldn't throw an exception because an exception happened while an exception was being thrown. Something like that. And that was because this code here, if the info array was null, it would try to loop through it, and obviously this would throw a null reference exception. And so yeah, that's what caused the problem. All I have to do is just check to make sure the info array does not equal null. And this is in our play exception class. And so now the game should run fine, but I don't... okay, so it still has a different error, but at least we can read what the error is now. So syntax exception in ability scripts, line 44. Unexpected symbol near greater than. So let's look at that. Ability scripts, line 44. Oh, okay. Pretty sure the greater than in numpaths. Not really sure why this would throw an error. Maybe because looks like I forgot to have a return statement. Of course, this is a little messy, but you could do local results just to clean this up, and then we'd return results equal, or we'd return results dot numpaths. Basically here, this ability is only usable if the number of paths that the algorithm finds is greater than 0. Okay, so let's try one more time. Okay, so yeah, something was going on, but it's a pathfinding cost, bad return. Okay, so I guess this isn't a very useful exception, is it? But I guess it just means somewhere in yeah, this function GetCost. Okay, well this is really simple. We always return a number. Okay, so it must be a problem on the C# side of things. Oh, hey, Yellow Cool Pokemon. Thanks for stopping by. I'm doing pretty well. How about you? Okay, so this throws... oh, yeah, this is backwards. It should be return value number less than or equal to 0. Yeah, I think that's fine. I just had that reversed. So it looks like another error, so cannot access field pathfinding results. Okay, well that's because we haven't actually implemented that yet, I think. Yeah, so yeah, this is expected. We saw your tweet. Oh cool, I'm glad that you're interested in the game. Oh, and thank you for following, I appreciate it. Okay, so this error is just because even though we try to access the pathfinding results on the Lua script, we haven't actually implemented this on the C# side of things. So let's go ahead and do that. Where is... oh, that's wrong. Wrong namespace. Okay, so it's the asynchronous response. Okay. So we need to add some new class here for pathfinding results. Okay, so I'm trying to think what type we'll name this. Because there's basically two return values actually. There's for the target mode, where it tries to find a specific path to a specific monster. It just returns one path. Whereas on the max cost mode, where it tries to find all paths of a certain length, then it actually returns like a collection of paths. So they're slightly different. But maybe we should wrap both in a pathfinding results object. So that way maybe the results would also return, for instance, like what type the pathfinding was and things like that. Okay, so this is going to be basically the C# side of an object that we can access in Lua, and in order to tell the compiler that that's what we want to happen, we have to use this moonsharp user data tag. And that basically just lets our Lua engine, which is called moonsharp, register this object. And whenever we do that, well, at least I don't ever want Lua to call constructors, so luckily there's a nice tag here, moonsharp hidden, which will make it so Lua can't access the constructor. And we'll probably have our own more detailed constructor to pass data into here. Maybe something, we might even just need an index. Maybe the Pathfinder manager. Let's just call it the manager. Because that way we can look up all the data about this pathfinding. Because it's the Pathfinder manager. Pathfinder manager stores everything based on this index. I think that'll be the best way to do it. Okay, let's put the manager first. And again, I want to hide this from Lua, because Lua shouldn't ever create this object. It will just be able to call. And the Pathfinder manager isn't public, so it's complaining about that. And so now we'll just save these values. And okay, so what do we want to return here? Well, obviously the actual path. So maybe the way that we'll treat it is if it's a target mode, we'll just have one specific path value. Whereas if it's in fixed length mode, then we'll have this get all subpaths and things. Actually, I did this a little bit backwards. It should be for path. And then we need to do another loop to get all subpaths of a specific path. But I guess we could have just get all subpaths that gets all subpaths in every path. I guess we'll just wait and see how I want to implement that. Okay, so obviously we'll need another class here, which will be for a specific path, but I'm not actually sure how we'll store this data because I don't think the game even reconstructs the paths from a pathfinding search yet. Okay, so again, we're just setting up this class to be used in oops, something's wrong. In Lua. Okay. Oh yeah, and also just to make sure that this isn't called in C# either, we'll have this little exception. Alright, so we'll have this, which will just return the first path. For right now, I guess we'll just return null so we can avoid that error. And then we'll have num paths. And then we have a whole bunch of different iterators. So let's see what it's calling. Trying to see. Okay, it's A* move. So let's try and get this one working first. Okay, and this is the one that's just a fixed cost. That's probably good to do first because it's more general than to a specific target. Okay, so first we'll need to implement this num paths, but I guess before we go any farther, we need to actually figure out how the Pathfinder manager will reconstruct paths. So basically, let's see here. Okay, so we have a list of end nodes. And so I guess that tells us the number of paths in this that the Pathfinder found. And then we can look back through the visited hash, I think. Let's see how... Oh wait, no. Oh no, the queue node itself actually contains the previous queue node. I think that's how I did it. So it's kind of like a linked list. Right, so we just look through each end path, and that way we can keep going backwards until we get to the first node. Probably for ease of use we should maybe reconstruct, like reorder this into an actual list. But maybe that'd be something that just the Lua would take care of. Or the LuaInterface object. Okay, so it looks... Okay, so should this subpath... Like, I know we're going to need to find subpaths, and that's basically, like I said here. So we have the path A, B, C, D. And for this get all subpaths, we want to get the path A, B, A, B, C, and A, B, C, D. And so how should we store that? Maybe the path should have, like, the path index, but then also, excuse me, also the beginning and end index. Or would every path always have the beginning? Probably. So yeah, I would just need an end index. So basically it'll have, it shouldnver be public. Path index and I guess subpath length. And then the pathfinding result will maybe have like a list of, where should it store it? Because we just want to have a list of queue nodes in order from beginning to end, and so we'd reconstruct that with these end nodes going backwards. And I wonder, maybe the Pathfinder should just construct that right away, or maybe as needed. So basically be a list of queue nodes. Or it could be an array too, but maybe we should make a entirely separate class. That way it could cache things such as like the total path cost. Yeah, so let's go ahead and do that. What should I call this? Path info is a good name as any. Okay, so the path info will be passed a queue node. And this will be the end node. And from there it can reconstruct the path as needed. Okay, so this will be order, and then I guess we'll cache the end node. And then I'll go ahead and create a value for the total cost. Although we won't really need this because the queue node, I think, yeah, this is the total cost, so you can just check the cost of the end node. But still it'll be fine to abstract this outward, I think. So here we'll just create a new object for the order and then set the queue node. I guess I should rename this end node. so I guess I'll just have something here, and then let's see. Cool, order, built. I guess, well, I was gonna say maybe we'd build the order just right when it's needed. Something called lazy construction. But I don't really know if we're gonna be saving that much space or time by doing that. And we might just make things easier on ourselves by just building the order up front. Okay, so let's see. I really don't like using while loops, so I'm just going to do a very long for loop. This way, if we somehow encounter a bug with like a pathfinding ring or something, which I don't really know how that could happen, but this way we won't ever have an infinite loop. So if I less than like 10,000 and in node, why did I use that? Previous is not equal null. Oh right, and then I just do I++. So I guess, because we don't actually add anything to the list, we just got to get to the very first. In order to get that, we can just recursively go backwards. So yeah, so while the previous does not equal null, we'll just go backwards. So yeah, if you have a path that's 10,000 long, this will cause a problem, but I think I feel pretty secure in not allowing paths with 10,000 steps. Okay, so now that we have the first, oh wait, this is, so we can't, now that I think about it, we can't do it this way because the Q node doesn't know the next node in the path. Okay, so how would I do this? Well, the easiest way is just to kind of insert everything at the beginning of the order, but that's not very efficient. Or we could just build out the list and then kind of and then reverse it. That'd probably be better. So yeah, well, order, add, start, or let's just rename this to node. So yeah, well, node previous is not equal null, we'll just add it. But actually, we'd want to add it even if it equals null because we'll want to add that specific node. So I guess we just need to do this one more time. That's just because obviously when the previous node is null. Oh, well, there's an easier way to do this. Just if the end node, or if node does not equal null, then we'll add it to the list. Yeah. And then node equals node.previous to loop through. Okay. So now we see that the node becomes null when previous is null, and so then it would stop the loop. Okay, so now we need to reverse the list. I'm not sure. Does C#? Okay, they do have a function that will do it for me. I wasn't sure if they had one that would do it in place. Okay, well that makes that easy. So here we'll just return order. Okay, I guess that's really... Okay, well no, then we'll have public double total cost, which is just int node dot cost. Okay, yeah, so not much going on here, but I think it'll be good to have this kind of middleman class in between the actual pathfinder and the LuaInterface pathfinding results. Okay, so we'll have private list path info. So here we'll have is complete. Just trying to see where I want to add this stuff. We'll need to have int num paths, and this will just return int nodes. Count. Okay, so one thing I just noticed is that the end nodes down here, before I add it to the end nodes, I make sure that that here I make sure that the end node is unique. So that way, I mean, if there's two paths to the same end node, it won't be recorded here. Is that something I want to happen? Probably not. Okay, so I'll leave this commented, but yeah, for now we won't check for unique end nodes because on one hand it is useful, but if this is going to if this is how we're going to store paths. Oh wait, so the end node is not actually like a specific position. This is actually encodes the entire... Oh wait, no, it is just the head. Sorry, I'm sure I'm confusing everyone. I was gonna say, here we actually... The end node actually contains the entire path, because that's how we store it, but here we actually just check if the node head equals neighbor. So yeah, we won't do this at all. There won't ever be a duplicate path. Okay, so yeah, now that I've confused everyone, let's move on to, so this will be get info and path index. And how I'll do it is basically if, let's do it this way, path info equals, oh, I can't do that. Let's rename this to something a bit more descriptive. Okay, so I'm going to use my safe get function, which instead of, like, whenever you use lists, you need to make sure that you don't search for an object outside the bounds. So for instance, if the list was only 2 elements long and you wanted to get the third element, then that would throw an error. Well, safe get just returns null instead of throwing an error. So then if info is null, then we know we need to actually create the path info. So info equals new path info. Why did it not pull up the constructor? Oh, because it's private. So end nodes path index. Oh. Keeps on doing that. So yeah, there's going to be one path info per end node. And then of course we need to actually set the value. And return it. Okay, so now in the Pathfinder Manager, we'll have a way to call the, or get the number of Pathfinders and then get a specific path info. So public int num paths. Alright, so we'll do a try get. I'm doing this backwards. So if Pathfinders try get value Pathfinder index. Okay, so this would return false if there is no value for this index in the dictionary. So if it's true, then we can actually return Pathfinders. Oh wait, so we already have the Pathfinder object, so we can just return num paths. Otherwise, I guess we'd want to throw an error. Runtime exception. Okay, well actually, no, here we'll just return -1. And the pathfinding results class will handle throwing errors. Okay, and then we'll have, so we'll want to get an actual path info class. Get path info. So again, we'll do try get. And otherwise we'll return null. So what is wrong with here? Oh, our path info is not public. Okay, so now it's happy. Okay, so now we have everything we need to actually return data here. So I'm going to err on the side of preventing bugs instead of speed, and the path won't actually contain a reference to the path info. Because that way, if the manager decides to clean up this Pathfinder, data won't still be hidden somewhere in our Lua scripts. Say I'll keep. So this will have the path index, and it'll actually have the finder index as well. So let's rename this finder index. Okay, so this will reach. I guess we'll need to have a list of paths. How do I guess I should cache these objects at least. but we'll actually create a whole lot of paths because there'll be the subpaths and everything. So I wonder if the best way to handle this is actually just to have like a list of paths, and then when okay, let's see. Actually, see, there'll only be two ways to iterate. It'll just be iterate through all paths and then all subpaths. So I guess we can get by with just two lists here. So full paths and then private list. This will be incomplete paths. Okay, so let's just use the same nomenclature. So incomplete paths will be paths that don't go from the beginning to the end, and then complete paths will be ones that go from the beginning to the end. And then when we call the all subpaths, we'll just loop through both of these. And so for target mode, there's only one path. So let's just be to find complete paths, and then we'll return complete path to 0. Well, actually, we need to check to see if any paths exist. Let's move this down. So if complete paths count is greater than 0, otherwise we'll throw new script runtime exception. No paths found. I guess then we could just return null. I'm not sure what would be better. Probably returning null, actually. I'll just leave this commented in case I change my mind. Okay, so numpaths would be manager numpaths finder index. Okay, so here if complete paths does not equal null, then we'll just return because we've already found the list. And let's see. So I guess complete paths is pretty simple. We just gotta loop through. Okay, so let's cache the numpaths variable. And then for, let's not do it that way actually, in case I end up changing the way this works. I equals 0, I less than numpaths. Okay, that's the path info. Do I need this? I'm not sure. I don't think I need that right now. So complete paths, add new path, and then we thought I did a constructor. Okay, not yet. So here we'll pass it. Saying path too much. And then the path index, and then sub path length. Okay, so I just need to store all these values now. Okay, there we go. So we just create a new path and create a new path and pass the values that we need. So that's I, and then the subpath length is actually, maybe there's a better way to store this. Should we maybe just store like Oh well, no, let's just do the whole length. Although I guess now we will need the info. Well, that's okay. So yeah, manager, get path info, so order, and then count. Oh, I need to pass the finder index. Okay, so yeah, this is the finder index, the path index, and the total length. Okay, so let's see here. So pathfinding results. Okay, I don't store that yet. So the async response will have public pathfinding results. Okay, then we just need to store that value here. So we'll hide the setter. That way we can easily set the value in C#, but Lua can't touch it. Okay, so I guess the last thing we need to do is when we actually create this object in the Pathfinder Manager, we need to go ahead and create the Lua Pathfinding Results object. So how should I do this? Maybe I should store the value in the Pathfinder? Oh no, I guess I don't really need to. I just call pathfinding results equals new pathfinding results, and then I would just pass ourself and the next finder ID. Okay, and now this will be ready to go once the finder is done. I guess, well, I don't think Lua can get its hands on it before the pathfinding is actually complete. But just in case, I should say if the finder exists and finder is complete. Okay, so did I hook up everything? So we did numpaths, it's right there. Okay, so now I need is get all subpaths. Okay, so I guess I do need to do that right away. Well, let's go ahead and play the game and wait until we get to that call, and it should throw an error. Okay, yeah, we already have some problems here. So I guess QNode is not public, so it's complaining to me. Do I need to make it public? Because I could probably just have these, just expose the head value, and then, yeah, I don't think I need to, so let's go back on that. Okay, and so it won't complain, this will be protected, or actually internal. And so this, the order won't be QNodes, it'll just be a dynamic value. Okay, so then we pass node head. Okay, so I think that's all good now. happy now, Unity? Oh yeah, there we go. So let's see how far we'll get. Once we actually get everything to run well, we'll probably want to create some kind of pathfinding visualizer. Okay, so there was actually an error. To call a number value, call script. Ability scripts 35. Oh, that's because numpaths isn't a function, it's just a property. Okay, so A star move usable is complete. So if I click here and pick A star move, okay, so now it goes on to call this. And actually, right now we don't cache searches with the same values, although we probably should, but so it has to search once more, and then I think it's gonna say that this get all subpaths doesn't exist, which we know. Yeah, cannot access field get all subpaths. So let's go ahead and build that. So first we'll need this find incomplete paths. Okay, and basically here we'll just use the complete paths list and basically make a path. Well, I don't even need the complete paths actually, because I don't think we'll need any information from it. We'll just need to create one incomplete path for every complete path going backwards. Now here there could be duplicate paths, and we will want to weed them out. Okay, let me get a drink, and while I'm doing that, I'll think about what the best way to accomplish that is. Okay, well, I think there's not going to be a really easy way. So I think for now we'll just won't worry too much about being super efficient, and we'll just loop through pretty much every complete path we've found so far and try and find duplicates. Most of the time it'll be pretty simple. So let's see, private boolean is unique incomplete. So how would I do that? So before, we won't actually create the path object yet. I guess we'd have the finder index. Well, no, because I have that already. So it'd be path index and then links, I guess. And then for each path in incomplete paths, So if, let's see. So basically, if the ending nodes are the same, and the length is the same, then we'll need to check every node in the path to see if there's any differences. So for right now, we don't have a way to get this information yet, so these will be hidden from Lua. Well, I guess this can just be links, it doesn't really need to be hidden. Yeah, no setting though on either of these. And then we'll need to have get. Okay, well I guess yeah, if the length is the same, then we'll first need to get the end node. So I guess either way we'll need to get the path info. So I think I'll do that here. So if length equals path length, okay, so then path info, I guess new info would be manager get path info. And then the old info is manager. And of course, okay, well, we can simplify this a little bit, I guess, because if the path indexes are the same, then we can pretty much know that they're not going to be equal because we won't add path indexes with the same length. So if and path index does not equal path index, so that means it could be different. So now we need to get the last node in each of these. And since it's a dynamic value, we need to test if it's equal. And I think we can just call the equals function. It works well. It's the hash code that doesn't. Okay, again, yeah, I'm spending too much time thinking about optimization. We can get to that later if this is super slow. But this is only going to be called once when an actual pathfinding query is done, so it's okay if it's not the most efficient. So if new info, I'll just create a last node just to make things a little easier on me. Oops. I wanted to generate. And this should be a dynamic value instead of a Boolean. And so then we just call order count -1, and yeah, this shouldn't ever cause an error because we won't even consider paths of length 0. Well, that won't even get this far because there would be no end node, so yeah, no need to even consider that. So if new info equals old info, and I actually only need to get this one time, I just realized. Yeah, I did this a little wrong, but so yeah, this should be the path index, not the actual path index value we passed in. Okay, so if last node equals old info last node. So now we need to check every node in the list. So do this for int I equals 0, I less than new info order count. And since the lengths are the same, this okay, so this actually tests the path length and not the actual length of the info. So since every path has the same start position, if the path info lengths are different, then that means that they are also different. So yeah, if new info dot order count equals old info order count, and the last nodes are the same, then we'll go through and check every node. I don't really know if this speeds things up much. Okay, so I can speed this up a little because we don't need to check the first node, which is the start. But yeah, this doesn't really help me. Okay, so if old info, or let's do new info first since that's how we've done it before. Order I equals new info order I. Okay, so that means... okay, that doesn't mean anything actually. If there's any differences here, then we'd return true. But then if we make it through this entire loop, then we return false. And then if we make it through this entire... oh wait, no, this doesn't work actually. Yeah, let's split this out. We can't return there. But we should make this a little simpler. No, I called new info twice. So let's call this is order unique. And I guess we only have to actually check up until the length if they're equal. Okay, so if I equals 0, I less than new info order count. So it'll actually be less than length, because the length would never be more than the count. So now we need to pass that. Okay, so let's see. So if info order count is the same and is order unique is false, then we'll return false here. And then if we make it through this whole loop, we'll return true because that means it's a unique path. This shouldn't be unique, this should be is order equal. I guess I could put this inside as this function. Yeah, this is all kind of turned around. Okay, so yeah. This for loop goes inside, because if the counts are the same, then this could happen. And then if anything inside... wait, I'm confusing myself. So if the counts are the same, then we need to check here. So that's fine. And then we return true. But if the counts are different, then we'll also return true. Wait, that's equivalent to what I just had. Yeah, I have it flipped. So yeah, if the counts are the same... Okay, I just need to think this through. So if the counts are the same, then that means we need to loop through here, and we can disregard the beginning of every node, or of every path, because that's the same start position. And then if anything is not equal, then that means, of course, this is false. But then, so that means if everything is equal, then this won't fire and we get down here and so we can return true. But if the counts are different, we'd actually return false. Okay, so there we go. And then here, if is order equal, actually if that's true, then we return false because this is not unique. And then if we get through the loop, we'd return true because that means it is unique. And then again, yeah, if the path index is the same, then that means we can go ahead and assume they're different, because if not, we would have tested the path twice here, which is kind of weird, or tried to insert it twice. And then if the lengths are not equal, and since every path starts at the beginning and every path has the same beginning, then if the links are not equal, then they can't possibly be duplicates. Okay. So here, incomplete paths equals new. Num paths, we'll still need to do that. And then for int l equals 0. I guess we'll need to, let's go ahead and count the length. So it's not really, so I guess we will find all the complete paths, and then we'll go ahead and add it to this incomplete paths array. Because we actually do need to test the complete paths in this is unique complete. And I mean, we could loop through both, but that's just going to be a little bit confusing. And it's probably easier if the incomplete paths is entirely in here, so that's fine. So yeah, L. So 1, and then again here we won't try to create the full length path, so it'd be length -1. Okay, so yeah, if the length is less than the total length. So let's change this. Or let's call it complete length. And then how about instead of L, we just name it length. Okay, so if is unique and complete, then we'll add it here. I don't need to do that. Okay. Phew, that was I knew I have to do quite a bit of work there, but it's all done. So here we have the get all subpaths, but what we actually want is to get all subpaths with a unique ending point. Because we don't really care if there's two separate paths that are different but they have the same end path. I mean, if they're different but they have the same end node, we don't really care at this point. Well, now that I think about it, the whole point of A star is to find the shortest paths to every position. So I wonder, if we shouldn't include, let me see here. So the Pathfinder, yeah, that's the reason why I only added, actually we didn't, okay, yeah. So the reason we only added unique end nodes here is because only the first one is going to be guaranteed to be the shortest. So I wonder, I'm trying to think, would there be any reason why in this game you'd want to take a path that's not the most, I mean, that's not the most efficient. I'd say I can't think of any right now. And I guess if for some reason you ever wanted to, it would be just as easy as setting a flag in the Pathfinder to save duplicate paths. Yeah, so yeah, I guess I will add this in. Okay, so now the end paths will have one unique path per end node, and it will be guaranteed to be the shortest. But that doesn't mean, like, the subpaths can still have duplicate end nodes. And I don't think we want that. But we also want to find the shortest to every, or the shortest subpath to every end node. So I wonder, that almost seems like something that we should actually store in the Pathfinder. Like, we'll have a dictionary for every Q node of the shortest path to that node. So maybe I have been going along this a little bit more complicated than need be. So here, if I just have, so we have these end nodes, we'll still need that, but then we'll also have a dictionary for each Q node. So how would we hash that, now that I think about it? Because the whole problem is that we would just use a hash set, the visited. So does visited, it always contains the best node, doesn't it? Because that's the first time it's come off the priority queue. Okay, so we already have everything we need. So then visited, that contains all subpaths, doesn't it? So I've made this, yeah, we can just use that, can't we? Okay, so how... So I guess all we do is this path info class, we just pass the Q node for a specific visited node. Okay, yeah, that's how we do it. But we can't lazily create those. We have to just have a complete list. I guess that's fine. But now I'm thinking that if we're going to have all these path infos, and they're actually pretty simple, maybe the paths themselves should just, or the Lua here should just access the queue nodes directly. How much difficult would that be? I mean, I guess they'd have to store a list inside for when we actually iterate down the path the correct way. Okay, so yeah, but don't need this at all. Okay, have a few more minutes. So I guess the path would actually have, I don't really want to store the, let's see, the queue node, it just contains other queue nodes, it doesn't actually hold on to the Pathfinder object, so that might be okay. And from the queue node we can actually reconstruct everything that we'd want to know about a path. So let's see, do we need to store this information anymore? I guess no, because now they're guaranteed to be unique. Okay, well, I'll leave it just in case. So we have the queue node, and this is the ending node. So yeah, then I'll leave these for now, but I don't know if I'll actually use them. Oh, semicolon. Accidentally typed. And let's see. So now I can reconstruct the path length and everything just by going backwards to the end node as needed. So pathfinding results will still need to have this reference though to the incomplete paths or to the finder index. So somehow we'll need to get this visited hash and then also just the end node hash. So why don't I just make that available? And so here was still yeah, I don't know if I'm gaining much here by trying to like only gate specific things, because I mean the pathfinder results is like so integral to the actual pathfinder, especially because we don't want things to get too complicated. I don't know if it's actually going to save us much trouble to try to keep it decoupled, because they're, like I said, they're so like integral to each other. The main thing is we want to keep Lua decoupled from the rest of the game, which we're doing with this pathfinding results object, but the actual pathfinder manager doesn't really need to be. So let's just have get pathfinder. So then we'll just return finder and return null. What does it not like about this? Okay, yeah, Pathfinder is not public. Okay, so again, I don't want to actually store it, so we'll always just use the get pathfinder dot numpaths. I guess I should check for errors there. Okay, now I'm out of time. Okay, so if finder is null, then I'll throw an error. So throw new script runtime exception, pathfinder disposed. Which basically means that this pathfinding result is invalid, so you shouldn't use it anymore. So basically what we need to do, we'll still use the complete paths, but I might just change this to, I wonder if it would actually save a little time to find both at the same time, but I don't know, because not every pathfinding results will need the incomplete paths. So it's probably fine to have these lazily constructed. But anyway, so here, use the end nodes list, and then here we'll use visited list. Okay, so now, yeah, and this will be a lot easier because visited is already guaranteed to be unique. So yeah, all this work we did here is kind of unneeded. And also, everything in the visited list will always be the shortest path to that end node, which is the whole point of A-star pathfinding, yeah, so I kind of lost sight of that. But anyway, yeah, we'll finish this up tomorrow and hopefully start on like visualizing the path. I want to draw little arrows on the map from wherever the paths go. Oh, I can't play it right now, but okay, I'll just make these internal. But yeah, we'll finish this up tomorrow. So yeah, thanks everybody for coming by, and I'm glad that my wireless connection held up well, so I should be able to stream the rest of the week. Friday, they're gonna come and actually work on my network some more, do some more repairs and stuff, so I probably might not be able to stream that day. I don't know exactly how long it'll take. But anyway, if you missed some of the streams and you want to catch up, feel free to check out my YouTube channel, which you can find in my video or channel description. And also I have a Discord channel if you want to chat with me, other viewers and developers. I'd really love to have you there. To get an invite, you can also look in my video and channel descriptions. And yeah, I'll be back tomorrow around 8:30 Eastern. And thanks again for stopping by, everybody. Have a good night. Bye bye.